Do I have sound? Yeah. Okay, yeah, thanks so much for having me. Just to get a slight feel, how many of you have ever done any metaprogramming? Show me a hand. So it's sort of a trick question because I'm pretty sure if you've ever programmed in JavaScript, you've done some metaprogramming. You just don't know it. I'm Eirik. I'm an independent consultant and JavaScript trainer from Oslo. And I spend most of my days either building things in JavaScript or teaching JavaScript and the React stack. And for a while now, I've been pretty hung up on metaprogramming. And when I think about metaprogramming, I think about these guys, wizards doing wizardy things, because at first, at least, a lot of it feels indistinguishable from magic. But what is metaprogramming? So I try to ask Wikipedia, and Wikipedia says that metaprogramming is the ability to treat programs as data, and the ability to read, generate, analyze, or transform other programs, and even modify itself while running. So I think I'll go with that. And there's two main branches of metaprogramming. One of them is macros. And macros enables you to create your own syntax. So here's an example where we use Sweet.js, which is a macro system for JavaScript, to create some custom syntax. So I'll make my own syntax here, and I can use that syntax in my code. And before that code actually runs, it gets compiled to whatever that syntax means. And you can also make your own operators. So let's say that I'm really tired of saying .then. I don't like writing .then when I'm chaining promises. So I'm making my own operator for that. So now I can use that operator in my code. And before that code actually runs, it's compiled down to actual promise chaining. So you can use macros then to sort of extend your language, create your own dream language. And all of this stuff happens during compile time, or possibly in something called macro expansion time. At least it happens before your code runs. And the second branch is reflection. And reflection has some sub-branches, where one of them is introspection, meaning that the code can inspect itself during runtime. You have self-modification, meaning that you can change your code during runtime. And then you have this thing called intercession, meaning that the code can intercept and intervene with itself. So a simple example of introspection would be, let's say we have an object with some properties here, and I use object keys to check which properties exist on this object, and it gives me a result back. So this is one of the simplest examples of introspection. And then you have self-modification. Let's say that I have a function. I have a grumpy sum function that usually returns the sum of A and B. But if you ever pass an A that's larger than 5, it'll just rewrite itself to just return 0. So if I pass 1 plus 1, that's 2. If I pass 10 plus 1, that's 11. But then it just starts returning 0. So we've actually changed the functionality here during the runtime while the code is running. And then we have intercession. Intercession is something that you can do in JavaScript already, sort of, by using object-defined property. So let's say we have a hero here, and he has a health property. But we also want to have a status field that is somehow based on his health. So we'll define a new property, status, and we'll define a getter for that, saying that if his health is larger than 50, he's fit like a champ, otherwise he's badly hurt. So here we have a property which functions based on the runtime conditions. But this sort of intercession in JavaScript is pretty limited. So all of this reflection stuff happens during runtime while our code is running. And that brings us over to sort of a natural question now is, why is all of this useful? Why do we need this? So I went and asked Wikipedia again. And Wikipedia's answer is, in some cases, this allows programmers to minimize the number of lines of code to express a solution and thus reducing the development time. I think I'd rather say that the reason why this is very useful is because we want as much expressivity as possible to model our problems. And what we want is these elegant and developer-friendly interfaces. And this brings me to an interface that I'm pretty sure that a lot of you are familiar with, which is proxies, in the form of proxies on the web. So a proxy is usually a server placed in front of one or more servers. And this is to abstract away complexity and to provide a single interface for the consumer. So this enables you to actually intercept any interaction with the interface. And the use cases might be load balancing, it might be delegating based on where the resources are, and so on. But the main thing is that you're providing a single unified interface for the consumer, hiding all of these implementation details. And we can apply this concept more generally. It doesn't have to be servers. So we could instead place a proxy in front of a set of objects. We can intercept any type of access to these objects and provide an abstraction to hide implementation details. And this is what is made possible with proxies that was introduced in ES6. And what this enables is a much more powerful form of intercession, among other things, in JavaScript. And generally, this means that we're now able to intercept and define custom behavior for fundamental operations on objects. So that means property lookup, assignment, enumeration, even function invocation, and so on. And this is a very interesting feature for another reason as well, because this is one of the few features that essentially requires engine support. Unlike most of ES6, which is syntax sugar that can be transpiled using Babel, for example, this isn't actually viable with proxies. But thankfully, the support has become pretty good, except IE, which hopefully, doesn't stop you. So the proxy in JavaScript has its own constructor. And the constructor takes a target object and a handler object. And this target object can be any type of object. It can be a plain object. It can be an array. It can be a function, because functions are objects in JavaScript. It can even be another proxy. So you can proxy a proxy. Another important thing about proxies is that they're completely transparent. So if I say that I'm creating a proxy here with a plain object as the target, if I check type of this proxy, it'll give me object. So there's no such thing as a proxy type. It's entirely transparent. And then there's the handler object. And this is where we define so-called traps for all of these operations that you can do on objects. And here's an example with a getter trap, where we say that if you ever try to get a property from this object, we'll just return 37. So we can create a new proxy using that handler, And if I try to access A from this object or B from this object, it'll just keep returning 37. And for any available fundamental operation, there is a corresponding trap. So you have a getter trap, you have a setter, has, apply, and so on. And you also have this accompanying new API called the Reflect API, which can be used to perform all of these operations on objects. And an example of this is, let's say we have an object here with a property. We can use reflect.get to say that we want to get the health property from this hero object. So in the same way that there is a trap for every operation, there is a corresponding method in the Reflect API. So if we do a complete one-to-one mapping here, you'll get a proxy that is just a pure relay. It doesn't do anything. The object will behave just as it would have if you didn't wrap it in a proxy. So the nice thing now is that, as I said, you can now overload a lot of these fundamental operations, like the dot operator, the equals, and the function call. And one example of this is, let's say we wanted to add some instrumentation to our code. So we'll create a function that's called log access to properties. It takes an object, and we return a proxy with that object as the target object. And then we pass it a handler object with a getter trap, saying that, OK, if you ever try to get something from this object, I'll log out whatever you try to get. And then I'll return the result of actually getting that. And we can also add a setter trap, saying that if you try to set something, we'll log out whatever you try to set, and then we'll set that on the object. And the nice thing here is that the object that is being wrapped in the proxy doesn't know about it, and the proxy doesn't have to know anything about the object it's wrapping, so it's completely decoupled. So if you use this now, we can create an object, a bit lag here. We can create an object with some properties, and then we can create a proxy using this function, log access to properties. So whenever I try to access a property here now, it'll log out the access, and if I try to change something, it'll log out whatever you changed. And we can also use proxies to make observable objects pretty easily. So let's say we create ourselves a function called Observable, which takes an object that you want to observe, and then it takes an onChange function that we'll call whenever something changes. We'll return a new proxy, put the object in as the target, put in a handler which has a set trap, so whenever you try to set something on this object, we'll actually set it, and then afterwards we'll call the onChange method with whatever you updated. So if we want to use this, this isn't actually as useful as true observables because we have to overwrite the original object. But now we can create an object here that is observable. So if I change the name here, it'll log out name change to Frank. If I change the age, it'll log out the age change to 40. So all of this is nice, but it's not really something that would revolutionize how you write code in JavaScript. So I tried to think about, I didn't really want to do this talk before I had something useful to use proxies for. So for the last year, I've been working on a client project with a lot of people where we have a large amount of real-time data. Think something like Firebase. And we have a lot of data that looks like this. Let's say we have a collection. We have a collection of stories, and every story has an ID, it has a title, it has an author, it has a list of people that have liked this story, that have read this story, and so on. And what you can see here is that it's just references. And we can also imagine that we have another list here of people. And these people have authored books, they have read books, they have liked books. So what we see here is that these references are actually pointing to different objects. So the person 1 here is pointing to person 1 in our people collection, and story 1 here are all pointing to the first story. So what we really have here is, it's sort of a graph. So if we just consolidate this into an object, we have a collection of stories, and we have a collection of people, and they're all connected together in different ways. So what does it look like if you want to traverse this thing? Let's say you need to traverse this thing very deeply. So we can start out then. Let's say we want to find the name of the first person that liked the first story. So we'll go into the graph, we'll pull out the first story, we'll pull out the array of references to people who have liked it. We'll have to map it so that we can actually map it over to the actual objects. And then we'll have to choose the first element of that, and then we can pull out the name. Or if you want to find the title of the first liked story by the author, this is getting pretty deep now. We'll have to get the right collection based on this reference. We'll have to find the correct author, and then we can pull out the title from there. This gets really tedious. It would be so much better if we could just access this like it was a plain object. So that we can go into the first story, we can go into the liked by list, and then just assume that that's the actual object, not just a reference. And the same thing with the title here. So this would be a much better interface to interact with this graph. So what we really want our data to look like is something like this. Because what we have is just a reference here. We're in story 1, and it has an author. But what we really want is that author to be that object. And again, that has a list of stories that the author has liked. And we would just rather have that be the actual story, and so on. And this goes on infinitely, right? Because this is circular. So we need some kind of way of transforming this object that contains only references to an actually populated object here. So let's imagine that we could create an interface, a function called populate, which would take the graph as an argument, and then the node you wanted to populate. So as an example, we would want to have a populated version of the first story in our list. But how could we ever implement this? So the naive approach would be that, okay, I'll just use something like object assign and just keep filling this in recursively and until something just blows up, right? Because it's infinite. It's not possible. It's just not possible to do this in something that needs to evaluate up front. But this is a really nice use case for proxies. So with proxies, you can actually make this work, because even if it seems like we have to do this up front, we really don't have to. Because with proxies, just like with proxy web servers, we could just say that, okay, I'm in story 0, and I access the author. But instead of actually returning the reference, we could just redirect you to that actual object in the people collection. And if you then access the story there, we would just redirect you back. So now, using proxies, we can actually have this nice interface by pretending that this is an infinitely nested object, except it's just 2 flat lists in JSON. And I wanted to show some code examples of how to do this, but they just did not fit into the slides in any reasonable way. So if anyone wants to take a look, there's a open source version of this. And now I felt really excited because for the first time I felt that I had some proper use case for proxies, because this was something that you couldn't do without proxies. So I started to think about other things that I could use this for. And ding, I got a really good idea. Because we all have a beef with JavaScript, right? Undefined is not a function and cannot read property something something of undefined. And yes, I know about TypeScript and Flow, but there's no fun in that. So with this as a starting point, I figured I'm done with undefined not being a function. So first, I want to redefine undefined. So this is my own undefined, and it's actually going to be a function. The target object is a function, just an empty function, and I'll declare that this is going to have a getter trap. So whenever I try to get something from undefined, notice that there's one kind of leaky thing here, is that functions need to have names. So I had to kind of shim the name in here so that if you ever access name, this doesn't, you can't chain any further on that. But I'll just return undefined again. So if you try to access something on undefined, then you'll just get another undefined. And if you ever try to call undefined as a function, I'll just return undefined again. So now I figured we just need to make some seatbelts for JavaScript. So we have a function here that takes an object, and it returns a proxy of that object, and says that if you ever try to get something from this object, we'll check, does this property actually exist? If it does, and it's an object, we'll return another seatbelt wrapped version of that object, so that you can get this recursively. But if that property doesn't exist, meaning that it's undefined or null, we'll just return our new undefined here. And if it does exist, we'll return the property that you tried to get. So we can create an object here now using the seatbelt function, just a plain object that has some properties with some values. Seems to work fine. I can access foo. I can access this nested field. I can access name, and so on. But I can also do this now. I can access something that's not here, and something other that's not here that definitely isn't a function, call that as a function, and then pull out something else. And you know what? Function is, no, undefined is actually a function. So now you can do things like this. So no more crashing. You've got seatbelts. But so I was pretty pleased with myself. This was, I don't know, 4 a.m. But there's just one bump in the road. And that is, I figured, so this is nice, but I still have to use this seatbelt thing. I don't want to do that. I want this to be automatic. So I tried to do this. I wanted to set a prototype as a seatbelt object. And it turns out that someone smart had figured out that this is not good. And now this prototype object, the bottom level prototype, is a so-called exotic object, so you cannot overwrite the prototype. I even tried to look for any version that implemented proxies but not this exotic object. And I even considered compiling my own V8 for Node and then making this work, but I figured I'm just too far down the rabbit hole. This is ridiculous. So I figured I'd taken it too far, but it would have been fun. So with this, I was really sad about that. But in conclusion, you can use proxies for a lot of good things. You can make really powerful abstractions, and you can add a lot of functionality transparently. But the bad thing is that you can also just mangle things completely and introduce a lot of magic so that JavaScript doesn't really behave like JavaScript anymore. But all in all, I think this is another great tool in your toolbox to build your dream interfaces. So you should go ahead and figure out if you have some kind of thing you want to solve that just doesn't work in plain JavaScript. You should try to see if proxies can help you with that. And that's it.